Suppose anything Viladri. So it will be saved in this location C users HP. If you want in defined directory, just click here and store in defined. So you want in this directory only or your name directory?
Sir, this directory only.
This directory, okay. Then you cancel this and create project subdirectory. You tick this one, and then you create the next. It is the RTL project. Okay. Post synthesis project means you have if you synthesize in some other tools and you get the net list and then you import this here, then it is post synthesis project. Otherwise it is RTL. You are starting from Verilog code, so this will be RTL project. Do not specify the source at this time. No, I'll specify the source. Project is extensible. Okay. Next. Then here, if you in Notepad or in Word, you write the code, then you can add directly that file, .v file. Otherwise, you can create a file. Create a file in Verilog. So file name, suppose you give nil local to project, it is okay. It is Verilog project, okay. Now see, nil.v is created here. Xilinx default, synthesis and simulation. So I told both view should be required. So synthesis and simulation both is local to project. Now you add the, okay, you create next now. You select this one and then create next. So add constraints, this I will tell later. Constraint means some timing constraint you can add. So that means whatever your timing, you can mention that I want to complete the design within this time. So that file you can give. So that is the XDC file. So right now I am not giving that. So next. Now you have to select the device from here. Now category, we have all the device. So suppose all you select here, and family you select. We have RTX 7 board, we have Spartan 6 board, and we have Vertex 7 board, and Vertex 7 board we have, and RTX 7 board also we have, and Zinc 7000 board we have, and Basis 3 board also we have. So let's select RTX 7. Later on you can change from the settings.
What are these?
These are the series of FPGAs. Different kinds of FPGA. So we have this RTX 7. So suppose from RTX 7 also there are so many families. XC7 means Xilinx RTX 7 actually. So from there, these will be the package name and the speed limit and all those things. IO pin count, number of pins in these packages will be these. It will be varying, and available the input-output buffer. The input-output buffer also it is this much. So LUT elements are so many. So LUT means lookup table. Okay. So and these are the flip-flops available, and these are the block RAM available. Ultra RAM, DSP features if it is there, then DSP feature also it can support. And global buffer is there, that is BUFG, and GB transceivers and GPIe transceivers. Okay. So
all are compatible with that board which we have.
No, you can select our FPGA. On that FPGA, you have to see the serial number.
Okay.
That serial number you match here. First, that family, RTX 7 family board, under that board what serial number our board is having. I am suppose giving this one arbitrary. So later on we can change from if we interface the actual board. Then we will go to next, and a new project summary. It's whatever you configuration you have given, so you check this one whether that is created or not. Okay, that will be created, then click finish, then it will create the project window and that window will come. So this is the project window, it is coming. Now your module name is nil, so you okay this one. Suppose if you want some port name input output, so this you give as
Xilinx.
suppose A, input comma B you are giving input. So that is okay, and here input you give suppose sum, and you give sum and comma carry. So you select this as direction output. So you click OK. Now see, in design source this nil will be selected, and this means it is a hierarchical design. This branch is there symbol, this is a hierarchical design. So now you select this one, double click, here the coding window will come, and you can minimize this one. So here you see the template, coding template, time scale is already mentioned. So in here this much code will be automatically written. Module nil, suppose it is for half adder, so in module, so what you have to give after this, so you this is the module, so after this module name, so you assign ASSIGN, assign sum equals to space A caret B, A XOR caret symbol, where is it? This one, A caret B, and semicolon, and enter, assign carry equals to A and percent, percent and percent, A and B. Okay, now this is okay, so we will save the thing, simple as that. Now once you save it, first you have to simulate. So you select this one and you select the simulation, run simulation, run behavioral simulation. So this will be there. So this will try to access the security firewall. So for public network you don't click, for private network you allow the access, home network or private network. And now you see that here it is not assigned actually, it is giving Z and X value. So what you have to do is you select the thing, you select this and you right click. Now you force the value here. Here you select, right click, here you select and right click, some signal force is there, no? You can give by force. Now here you can force constant or force clock. So what will be A? A will be value constant. So force constant. So force constant you are giving. You can give hexadecimal or you can give suppose binary. Binary you are forcing the value. Suppose 1 0 1 binary 1 bit 1, and starting from 0 offset and cancel after time, suppose 20 nanosecond. Okay, now see here A 1 is there. Now B also you select and give right click, force constant, suppose 1 and 1 you give force value 1, and for starting it will be from 0 nanosecond and it will cancel after suppose 30 nanosecond, 30 nanosecond, and okay. Now here both are 1. Now you try to simulate by this one. Go to last time, go to time. No. This you have to simulate. Now here also you can simulate, run all. So you are getting this value. Okay, so if you maximize this, then you can add with the zoom. If you give clock, then also you can understand well that see this value is 1, so this is 1, so 1 1 it will be 0, some will be 0 and 1, so this is not yet assigned. So what you have to do is minimize the thing where it has done. Here it is done. So now this portion is 1 1, so it is coming, sum is 0 and carry is 1, so it is giving correct result. So for half adder simulation is done. So I told that simulation, only simulation, the logic is correct, but whether the hardware is created, no, hardware is not created. So you run the RTL analysis. So under RTL analysis, what is there? You can know the RTL schematic of this. Open RTL analysis, elaborated design if you open, so it will give the data flow of this. So okay, if you give, so it will give the just the data flow from the input data is coming, where the output data will go. So this will be the elaborated design. See, the sum and carry, I think it is okay. Circuit is okay. So circuit it has made. Now what you have to do is run the synthesis. So up to this the simulation is okay, the circuit they have made is okay, but the hardware is not yet created on chip. So you have to synthesize, run synthesis you have to give. So run on the local host. So number of jobs means 4 parallel process will be going on. So you just create OK, and now synthesis, when it is running, it is showing this one in the queue. So here it is moving. So